Welcome to lesson 11. This is the second part of what we started last lesson, connecting equations to graphs. In today's lesson, we're going to analyze different forms of linear equations. We're going to talk about the standard form and the slope-intercept form, and how these forms relate to their graphs. Your first learning target for today: find the slope and vertical intercept of a line with the equation ax plus by equals c. That is your standard form. Learning target number 2, take an equation of the form ax plus by equals c, which is standard form, and rearrange it into the equivalent form y equals mx plus b, which is your slope-intercept form. And learning target number 3, use a variety of strategies to find the slope and vertical intercept of the graph of a linear equation given in different forms. Our warm-up today is 11.1, titled Rewrite These. What they want us to do is rewrite each quotient. Quotient is the answer you get when you divide. They want us to rewrite them as a sum or difference. Sum is the answer you get when you add, and difference is the answer you get when you subtract. So they want us to rewrite these, instead of being in multiplication form, they want them in instead of them being in division form, they want them in addition or subtraction form. So anytime I want to get rid of a fraction form, I multiply by the denominator. So I could divide by 2. Now the 2's cancel each other out because they are diagonal from each other. And now I have to multiply everything here. So this would be 4x minus 10. Same thing here. This is in fraction form, which is division. So what I can do is multiply by -2. These now cancel out, and this becomes 1 minus 50x. Here, I can multiply by 25. These cancel out, and this becomes 5x plus 10. And now I could multiply this by 2. This cancels out. And this becomes negative 1/5 x plus 5. So anytime we want to get rid of a fraction, we are going to multiply by the denominator. You'll use this moving forward when you are trying to rearrange your linear equations. Our first activity is 11.2, titled Graphs of Two Equations. Here are two graphs that represent situations you have seen in earlier activities. The one on the left, we see amount in tank in gallons, and on our x-axis, we see time in minutes. This was the 450-gallon tank that was losing water at a constant rate. The one on the right, we have dried figs in pounds as our y-axis, and we have almonds in pounds as our x-axis. This comes from the problems we had where the person was buying dried figs and almonds for a field trip. The first graph represents A equals 450 minus 20t, which describes the relationship between gallons of water in a tank and time in minutes. Where on the graph can we see the 450 and where can we see the negative 20? So the 450 is right here. That is our y-intercept. The negative 20 we see along the length of the line here. The negative 20 is our slope. We're losing 20 gallons per minute. Number 2, the second graph represents 6x plus 9y equals 75. It describes the relationship between pounds of almonds and figs and the dollar amount Claire spent on them. Suppose a classmate says, I am not sure the graph represents 6x plus 9y equals 75 because I don't see the 6, 9, or 75 on the graph. How would you show your classmate that the graph indeed represents this equation? So if you remember from the previous lesson, we said that when an equation is in standard form like this is A, this is B, and this is C. And our slope equals negative A divided by B. So in this equation, I want negative 6 divided by 9. Both of these numbers are divisible by 3. So negative 6 divided by 3 is negative 2. And 9 divided by 3 is 3. So our slope is negative 2/3. We said that our y-intercept is C divided by B. So that would be 75 divided by 9. If we divide the top by 3, we get 25. And if I divide the bottom by 3, I get 3. This can be written as a mixed fraction of 8 and 1/3. So now if we look at our graph, we can see right here we're at 8 and 1/3. That is our y-intercept. And we can see our negative 2/3 is our slope. So this is the equation that represents this graph. Can the equation 6x plus 9y equals 75 be rearranged into an equivalent equation of y equals 8 and 1/3 minus 2/3 x? What steps would you use? So if we start with 6x plus 9y equals 75, first thing I want to do is move what is not attached to my y variable. I have positive 6x, so I'm going to subtract 6x. And if I subtract 6x from the left, I must subtract 6x from the right to keep it equal. Now I have 9y equals 75 minus 6x. 9y is multiplication. The opposite is division, so I'm going to divide by 9. If I divide the left side by 9, I must divide the right side by 9. So now I have y equals 75 divided by 9 minus 6x divided by 9. And we just showed in the previous slide that 75 divided by 9 is 8 1/3, and negative 6x divided by 9 is negative 2/3 x. So now we can see these two are equivalent equations. Can you now see the 8 1/3 and the 2/3 on the graph? If so, where are they visible? We already showed the 8 1/3 refers to our y-intercept, and the negative 2/3 refers to our slope. Our next activity is 11.3, slope match. Match each of the equations with the slope m and y-intercept of its graph. So, if we look at number 1, remember that we said slope equals negative a divided by b, and we said that y-intercept equals c divided by b. So in this one, I'm going to have a slope of negative 4 divided by 3. Negative becomes positive, so I have a slope of 4/3. So it's got to be b or c. I've got an intercept of c, which is 3, divided by b, which is also 3, and anything divided by itself is 1. So I have slope of 4/3 and y-intercept of 0, 1. This must match number 1. Now we look here. I've got slope of negative 12 divided by b, which is negative 4. A negative divided by a negative is a positive, and 12 divided by 4 is 3. So this has to be A or E. Now I can look at my intercept, which is going to be 8 divided by negative 4. A positive divided by a negative is a negative, and 8 divided by 4 is 2. So I need a slope of 3 and a y-intercept of negative 2. That's choice E, so that must be number 2. Number 3, we have a slope of negative 8 divided by 2. A negative divided by a positive is a negative, and 8 divided by 2 is 4. The only one we have that's negative 4, so D matches with 3. If we look at number 4, we have a slope of negative 1 divided by 1/3. If I'm dividing by a fraction, then I'm multiplying by its reciprocal. Flip it upside down. Negative 1 becomes positive 1 times 3/1 equals 3. The only one I have with a slope of 3 that I haven't used yet is A. So this must be number 4. Therefore, the only one we still have is C. That must be 5. So now we've shown how we can match each of the equations with its slope and its y-intercept. How would you describe the matching process or the strategy? Was it fairly efficient or laborious? Was it prone to errors? I tend to think this is a fairly efficient and quick method that does not have errors. Is the list of slopes and y-intercept, if the list of slopes and y-intercepts were not available for you to choose from, would you still be able to determine the slope and y-intercept? Yes, the slope is negative a divided by b, and the y-intercept is c divided by b. Would you still use graphs to make the matches if the graphing needed to be done by hand? That's up to you. Personally, I would still do it because I believe graphing by hand is pretty simple. Our lesson synthesis. Suppose Claire went back to the store to get more almonds and dried figs and spent $108 this time. Almonds cost $6 a pound and dried figs cost $9 a pound. Claire's purchase can be represented by the equation 6x plus 9y equals 108. Here are two graphs that represent the relationship between pounds of almonds x and pounds of figs y, and they give us graph A and graph B. Without calculating anything, can you tell which graph could represent the equation and which graph could not? A simple way, we notice that graph A has a positive slope because it is going up from left to right, and graph B has a negative slope because it is going down from left to right. So if we calculate our slope is negative A divided by B. That would be negative 6 divided by 9. Both numbers are divisible by 3. Negative 6 divided by 3 is negative 2. 9 divided by 3 is 3. So our slope is negative 2/3. Therefore, this must be graph B because it is the one with a negative slope. What does the vertical intercept mean in this situation? The vertical intercept tells the pounds of dried figs because that is the label on the y-axis. What is the vertical intercept of the graph? How can we find it? Well, on the graph, they don't give us any numbering, so we can't just look at the graph. But what we can do is we know that a y-intercept equals C divided by B. C is 108 and B is 9. 108 divided by 9 is 12. So our vertical intercept is going to be 12 pounds of dried figs. What is the slope of the graph? How can we find it? They don't give us any numbers to use, but we already figured it out by taking negative A divided by B, which was negative 6 divided by 9. We simplified it by dividing the top and the bottom by 3, and we found a slope of negative 2/3. What does the slope tell us about the almonds and dried figs? Almonds are X, pounds of dried figs are Y, so it tells us every additional pound of almonds means 2/3 pounds of dried figs less. We are going to lose 2/3 pounds of figs every time we add a pound of almonds. So our cool down is 11.4, features of a graph. Consider the equation 1.5x plus 4.5y equals 18. For each question, explain or show your reasoning. If we graph the equation, what is the slope of the graph? Well, in standard form, slope is always equal to negative a divided by b. We have 1/5, so negative a becomes negative 1/5 divided by b, which is 4/5. These are both divisible by 1.5, so that becomes negative 1/3. So our slope is negative 1/3. Where does the graph intersect the y-axis? It intersects the y-axis at the y-intercept. We know that y-intercept is c divided by b. So that is 18 divided by 4.5. Both of these are divisible by 4.5. 18 divided by 4.5 is 4. And 4.5 divided by 4.5 is 1. So my y-intercept is at 4. Where does it intersect the x-axis? To find that, we substitute 0 in for y. We get 1.5x plus 4.5 times 0, because if I'm on the x-axis, my y value is 0. That equals 18. Anything times 0 is 0. 1.5x is multiplication. The opposite is division. If I divide the left side by 1.5, I must divide the right side by 1.5. So x equals 12. Our only glossary term is equivalent equations. Equations that have the exact same solutions are equivalent equations. So if you are comfortable saying that you know all of your lesson goals for today, then consider this lesson a success. If you still have any questions, please bring those questions to class so that I can clarify them for you. Thank you for your time. I look forward to seeing you in our next lesson.